In this lecture, we will see the semiconductor material in detail. Normally, the materials are classified into three types: conductor, insulator, semiconductor. So, conductor, insulator, and the semiconductor. So, for conductor, we can pass the electricity through the materials. For insulator, we can't pass the electricity through the materials. And for the semiconductor, we may pass or we may not the pass, depends on the different applications. So semiconductor is the important component, important material used in the electronic industry. So in this lecture we will see the detail about the semiconductor material. So first I will explain this what is the semiconductors. For semiconductor material, the valency of the material is the 4, means in the outermost orbit of an atom the number of electrons are the 4. So as the number of electrons are the 4, so these elements is taking the part in the chemical reaction, and for taking the part in the chemical reaction they can accept or they can donate or they can share these 4 electrons with the another elements, so they can complete their octet state. So the valency of this semiconductor material is the 4. And now we will see what is the classification of the semiconductor. The semiconductor materials are classified into two types. One is the intrinsic semiconductor, another is the extrinsic semiconductor. So intrinsic semiconductor, which is the pure form of the semiconductor, and the intrinsic semiconductor, it is the impure form of the semiconductor. So we will see the details about this extrinsic and intrinsic semiconductor. Intrinsic semiconductor, it is a pure form, which I will explain with a simple example. For the gold, we are using the gold in the two ways. One is the 24 karat gold and the 22 karat gold. So for 24 carats, it is a pure form of the gold, and the 22 carat, we are adding some impurity. Just example as the copper. So copper we can add in the gold, so it will form the 22 karat gold. So similarly, we can have the semiconductor, it is in the pure form and it is the impure form. So pure form of the semiconductor is called as the intrinsic semiconductor. Impure form of the extrinsic is called as the impure form of the semiconductor is called as the extrinsic semiconductor. Now we are adding just for the gold we are adding the copper as the impurity. So for extrinsic semiconductor we are adding their impurity to use these materials in the electronic industry. So the process of adding the impurity is called as the doping. The process of adding the impurity is called as a doping, and the material which is added as the impurity is called as a dopant. So remember this new term. So doping is the process of adding the impurity to the pure form of the semiconductor is called as a doping, and the element which is added is called as a dopant. So you can add the impurity as a dopant as a two ways. One is a trivalent impurity, the element which is having the trivalent, and the pentavalent impurity. So it depends on the which impurity added. We have two types of the semiconductor: extrinsic semiconductor, N-type semiconductor, and P-type semiconductor. So in the N-type semiconductor, when pentavalent impurity is added, so semiconductor is called as the N-type semiconductor, and when trivalent impurity is added, so it will form P-type semiconductor. So I will summarize the semiconductor materials classified into two ways: intrinsic semiconductor, extrinsic semiconductor. Intrinsic semiconductor, this is in the pure form. Extrinsic semiconductor, it is in the impure form. So in extrinsic semiconductor we are adding the impurity to the intrinsic semiconductor, it will result to the extrinsic semiconductor, and the process of adding that impurity is called as doping, and the element which is added as an impurity is called as a dopant. So according to which type of impurity is added, we have two types of extrinsic semiconductor. The first is N-type semiconductor, another is the P-type semiconductor. For N-type semiconductor, pentavalent impurity is added, and for P-type semiconductor, trivalent impurity is added. Now we will see details in N-type semiconductor and P-type semiconductor, because it performs very important roles to construct any equipment or any components in the electronics industry. Now we will see details about the N-type semiconductor. So as already we discussed this, the pentavalent impurity is added to the intrinsic semiconductor. It will form the N-type semiconductor, and it is called as the extrinsic semiconductor. It is the extrinsic semiconductor. Pentavalent impurity is added there. So which are the pentavalent impurities? These are some example of the pentavalent impurity: antimony, arsenic, phosphorus. Remember these examples: antimony, arsenic, phosphorus. These are the example of the pentavalent impurity, and these are added to the extrinsic semiconductor. So it will result N-type semiconductor. Now we will see the details about the electronics configuration of the N-type semiconductor. So antimony, arsenic, phosphorus, example of the pentavalent impurity, and this impurity is called as a donor impurity. This impurity is called as the donor impurity. Now I have taken there one arsenic element. In one arsenic element, as we know, the valency of this pentavalent impurity is the 5. The valency of pentavalent impurity is 5. So number of electrons in the outermost orbit are the 1, 2, 3, 4, 5. These electrons in the outermost orbit will share the electrons with the neighboring silicon atoms, and they will complete their covalent bond. They will complete their octet state. So arsenic elements, I have taken these arsenic elements, and arsenic element, it has the 5 electrons in the outermost orbit. Now each electrons will share 1 electrons with the neighboring silicon atom, and it will complete the octet state. So similarly, these electrons, it will share the electrons with this electron with share this electron with this electron with share the electron with the silicon atom, neighboring silicon atom. Similarly, this electron will share the electrons with the neighboring silicon atom. Now when sharing this, so the one electron remains free in this arsenic element. So this electron is responsible for the conduction. This electron is responsible for the conduction, and as we know the number of electrons are flowing, so we can say the current is flowing through the circuit. So for each arsenic elements, the 1 electron remains free to flow the electrons, and it will move in the conduction band. It will move in the conduction band. So number of electrons moves depends on the number of arsenic atoms used. Suppose I have to create the 100 free electron, so I have to add their 100 arsenic atom. So the 100 electrons are responsible, or the 100 electrons are moved from 100 free electrons are moves in the free conduction band, and the current will flow through these materials. So arsenic elements, it has the 5 valence electrons. Each electrons will share the electrons with the neighboring silicon atom. So when sharing these electrons, the 1 electron remains free to move in the conduction band, and this electrons is responsible for the conduction of the current through the materials. And the impurity added, this arsenic, antimony, phosphorus, this impurity added is called as a donor impurity. So the majority carriers in these are we will explain this majority carriers: electrons, and minority carriers are holes. Minority carriers are the holes. So electrons, it has the negative charge. Electrons has negative charge. So this is called as the N-type semiconductor material. Now we will see what is a P-type semiconductor material. So P-type semiconductor material, when the trivalent impurity is added to the extrinsic semiconductor, the resulting semiconductor form is called as a P-type semiconductor. The example of the trivalent impurities are boron, gallium, indium. Boron, gallium, indium. these impurities are called as the acceptor impurity. For n-type semiconductor, the impurity added is called as a donor impurity, and for p-type semiconductor, the impurity added is called as the acceptor impurity. Now we will see the electronics configuration of this p-type semiconductor material. So at the center we have taken the boron as the element which has a trivalent impurity. So the valency of these elements is the 3. For boron, the valency of the element is the 3. So 1, 2, 3. Now these electrons will share the electrons of neighboring silicon atom, and it will complete their octet state. It will complete their covalent bonding formation. But the neighboring silicon atom, when shares the electrons with this boron, so there is no any electron, so it will not complete their octet state. Means for this it will not complete their octet state. One electron is there for the silicon, but for boron already the 3 electrons are shared there, so there is a lack of 1 electrons, and it will lose the vacancy, and that vacancy is created in terms of the holes. The vacancy is created in terms of the holes, and this hole moves in the conduction band. As we know, the current may be flow either due to the electron or due to the holes. So this hole is responsible for the conduction of the current. As the hole moves, the current conduction takes place, and similarly the number of holes created depends on the number of elements added. Means if 1 boron atom is added, 1 hole is created. Again, if I want to create the 100 electrons, so I have to add there 100 boron atoms. So the number of holes created, it depends on the number of impurities added there, and this impurity is called as the acceptor impurity. Again, this boron, the hole is created. As hole is created, hole is having the charge, positive charge, positive, so this semiconductor material is called as a p-type semiconductor. P stands for the positive. And similarly for n-type semiconductor material, it is a negative charge, negative n. Initially n stands for this n-type semiconductor, n stands for the n-type semiconductor. So this is about the semiconductor materials classifications and details electronic structure of the p-type semiconductor and the n-type semiconductor material. In these lectures we studied the semiconductor material in the details. Now these p-type and n-type semiconductor materials, when combined together, so they will form the different components used in the electronics. So the first component, when p-type and n-type semiconductor material combined, forms p-n junction diode, and when 2 p-type or 2 n-type sandwiched between another p-type or n-type semiconductor, it will form another component that is called as a transistor. So that we will see in the next video lectures, transistor and the diodes, detailed configuration of the diodes and the transistors. So if you like these lectures, you can share, you can subscribe, so that you will get the information, and you can subscribe your channel to get the new updated video lectures. Thank you for looking these lectures. Thank you.